Hi, welcome. In this video, we'll learn how to solve for competitive equilibrium price and allocation in the following economy. So it's an exchange economy with three consumers and two goods. Individual one's preferences are represented by utility function 2x1 plus y1. Individual two's preferences are represented by utility function x2 plus 2y2. And individual 3 has lexicographic preference of x over y. What that means is the following: that an individual strictly prefers bundle x3 y3 to x3 prime y3 prime if and only if either x3 is bigger than x3 prime, or if that is not the case and x3 is equal to x3 prime, then y3 must be bigger than y3 prime. So if any of these conditions hold, then x3 y3 is strictly preferred to x3 prime y3 prime. Okay. Endowment of individual 1 is 4 0, endowment of individual 2 is 0 4, and endowment of individual 3 is 6 6. So let us solve for the competitive equilibrium. Okay. In order to do that, we just need to solve for prices at which demand equals supply. Okay, so what we can do is we can straight away rule out the possibility of zero prices. The reason is because of the kind of preferences the three consumers have. If any of the commodity has zero price, then that commodity will be demanded in infinite quantity by the three consumers, and will also be affordable, but the availability is finite, so that cannot be a competitive equilibrium, because there will always be an excess demand for such a commodity. So both the prices must be positive. If at all the competitive equilibrium exists, it must be the case that both the prices must be strictly positive. So what we can do is we can take price commodity y as numerator, and let px denote the price of commodity x, and let py be 1. Okay, so that's the numerator commodity. Okay, and we just need to solve for px. Okay, we need to find px at which the demand for x equals supply of x, and demand for y equals supply of y. Now since by Waller's law, if market for x clears, then market for y also clears. So we just need to look at one of the markets, which is, let's say, market for x, and we just need to find the price px at which the market for x clears. Because once we get that, then that's automatically going to guarantee that market for y also clears. So let us solve for such a price of x at which market for x clears, and this will be the procedure to solve for competitive equilibrium. Okay. So let me just draw a table. Okay. Okay, so these are the possibilities for price of x. At that price of x, at price px, this is the demand for x by consumer 1. Okay, this is demand by consumer 2. And this is demand by consumer 3. And this is the total demand for x. Okay, and here we are going to compare it with the supply of x. Okay, so if you just look at the utility functions, given that the marginal rate of substitution of consumer 1 is 2, marginal rate of substitution of consumer 2 is half, and consumer 3 has lexicographic preference, so he's always going to choose to spend all his income on X, we can actually consider these cases. So one is that Px is between 0 and half. The other possibility is Px is equal to half. Okay, and then we have the possibility that Px is between half and 2. Okay, and then the other possibility is Px is equal to 2, and then we have this possibility that Px is greater than 2. So we'll explore these 5 possibilities, and the reason for taking these values as half and 2 is basically because of the marginal rate of substitution of consumer 1 is 2, and marginal rate of substitution of consumer 2 is half. So this will give you different cases, for prices under which the demand can behave in a certain way. So let's figure out the demands in these cases. Okay, so the first of all, what is the income of consumer 1? Okay, so income of consumer 1 when price of X is Px and price of Y is 1 is nothing but the value of the endowment of consumer 1. So M1 is 4Px, M2 is 0 times Px plus 1 times 4, which is 4, and M3 is 6 times Px plus 6 times 1, which is 6Px plus 6. Okay, so let us now figure out the demand by 1. Okay, now when Px is between 0 and half, notice that all 3 consumers will spend all their money on X. Consumer 1, because MRS is 2 and it is greater than Px, and Px is basically between 0 and half, so Px is also less than 2. So the consumer will spend all his money on X. Same holds for consumer 2, because Px is less than half and MRS is half, so consumer 2 is also going to spend all his money on X. And consumer 3 has lexicographic preference of X over Y, so consumer 3 will also spend all his money on X. So let us figure out the demand by 1. So the demand by 1 will be 4Px by Px, which is 4 units. Demand by 2 will be 4 by Px, and demand by 3 will be 6Px plus 6 by Px. Okay, and if you add them up, you'll get the total demand for X at price Px, where Px is between 0 and half, and that's going to be 10Px plus 10 by Px. Okay, so if you just add them up, you're going to get 10Px plus 10 by Px, and this is clearly greater than 10, because the supply is 10, right? Supply of X is 10 units, and you can clearly see this is greater than 10. In fact, this is 10 plus 10 by Px, so the excess demand is 10 by Px. Okay, so clearly no price between 0 and half clears the market, so this case is ruled out. Okay, now let us consider the case when Px is half. So notice that when Px is half, again, because Px is less than the MRS of consumer 1, so consumer 1 will continue to spend all his money on X. Consumer 2 in this case, because Px is exactly equal to MRS, so consumer 2 can choose any anything between 0 and spending all the money on X, which means that 0 and 8, because 4 by half is 8. So consumer 2 is indifferent between choosing any quantity of X from 0 to 8, and the remaining money will be spent automatically on Y, so that's why. So consumer 2 can demand anything from 0 to 8 when price of X is half, and consumer 3 will continue to spend all his money on X. So this is 6px plus 6 by px. Okay, and if you just observe this, what you're gonna get is that because px is half, so this is 6 by 2, which is 3 plus 6, 9 by half, which is 18. Okay, so clearly, if you see, the total demand is going to be at least 22. Even if consumer 2 chooses 0, the total demand is going to be at least 22. So it is going to be anything between 22 and 30, and it is still not going to clear the market because there is an excess demand for X, by at least 12 units, okay, at price px equal to half. So this case is also ruled out. Okay, so the next possibility is that px is between half and 2. Now when px is between half and 2, so consumer 1 will still spend all his money on X. So the amount of X that consumer 1 can afford is 4px by px, which is 4 units. Consumer 2 will demand at px between half and 2 0 units of X, because now the MRS is actually less than the price of X. So the consumer 2 will spend nothing on X, and therefore will demand 0 units of X. Consumer 3 will continue to spend all his money on X, so the demand for X is going to be 6px plus 6 by px. Okay, and notice that the total demand in this case will be 10px, because px 4px plus 6px is going to be 10px plus 6 by px. And notice that this is 10 plus 6 by px, okay, and which is clearly greater than 10. So still there is excess demand for X. So this case is also ruled out. Okay, now the next case is px equal to 2. Okay, so in case of px equal to 2, in case of px equal to 2, consumer 1, if you see, MRS is exactly equal to the price of X, so MRS is 2 and px is also 2. So the consumer 1 can spend any amount on X from 0 to 4px, okay, and therefore anything between 0 and 4 is a possibility, okay, and in fact everything is a possibility, and he can actually choose anything between 0 and 4. Everything is utility maximizing. Okay, consumer 2's demand for X will be 0, and consumer 3 again will spend all his money on X, so the demand for X will be 6px plus 6 by px, which in this case is going to be, if you substitute 2 over here, you will get 12 plus 6, 18 by 2, which is 9. Okay, so notice that the demand for X can be anything in this interval, 9 to 13. And notice that 10 actually lies in this interval. Okay, 10 belongs to this interval. Okay, So this is a competitive equilibrium price, because 10 is market clearing, and if the consumers demand 10 in aggregate, that is going to be market clearing, and that's a competitive equilibrium. Okay, so let us also check for px greater than 2, and then we'll write this allocation. So let us see if there is another competitive equilibrium or not. So notice that if px is greater than 2, then demand by 1 of commodity x will be 0, and demand by 2 of commodity x will continue to be 0, and demand by 3 of commodity x will be 6px plus 6 by px, which is going to be 6 plus 6 by px. And notice that 6 plus 6 by px is actually, when px is greater than 2, is actually less than 9. So when px is greater than 2, this term will be less than 3, so the aggregate demand will be less than 9, and the supply is 10 units. Supply of x is 10 units, so you can see that there is excess supply of x at any price greater than 2, so px greater than 2 cannot be market clearing. So we only have one competitive equilibrium price, which is px equal to 2. So px equal to 2, py equal to 1 is a competitive equilibrium price. Okay, and what is the corresponding allocation? So notice that x3 is 9. So let's just write that. Okay, x3 is 9. Okay, what about x1? Okay, x1 is 1, x2 is 0. Okay, so this is the consumption of x by the three consumers. Okay, x1 is 1, x2 is 0, and x3 is 9. And let us figure out the corresponding y values. So what is the income of consumer 1? It is 4 times 2, which is 8. Okay, out of which the consumer spends 2 on commodity x, so the remaining money will be spent on y, which is 6. So y1 will be 6. Okay, and what about y2? Now consumer 2 spends all the money that the consumer 2 has on y, so y2 is 4, and consumer 3 spends all the money that consumer 3 has on x, so y3 is 0. And this is the competitive equilibrium allocation, which is 1,6, 0,4, and 9,0. So this is the competitive equilibrium allocation supported by these prices. Thank you.